Explain the theory of plate tectonics. How does the movement of tectonic plates shape the Earth's surface? The theory of plate tectonics explains that the Earth's outermost layer is not one solid piece but is broken into several large and small pieces called tectonic plates. These plates, which make up the rigid lithosphere, move very slowly, usually only a few centimeters per year, over a hot semi-molten layer called the asthenosphere. This movement is powered by the convection currents in the mantle, which are created by extreme heat rising from the Earth's core. The movement of these plates shape the Earth's surface in three main ways at the areas where they meet, known as plate boundaries, convergent boundaries, moving together. When two plates move towards each other and collide, they can push the crust upward to form fold mountains such as Himalayas. If an oceanic plate hits a continental plate, the oceanic plate sinks, which leads to volcanic activity and earthquakes. Divergent boundaries, moving apart. When plates pull away from each other, molten rock or magma rises from deep inside the earth to fill the gap. This process forms new crust and creates features like mid-ocean ridges. Transform boundaries, sliding past. In some places, plates slide past each other sideways. This movement does not create or destroy land, but the friction between the plates is a major cause of earthquakes. By constantly moving and interacting, these plates are responsible for building mountains, valleys, and ocean basins, as well as determining where volcanoes and earthquakes occur around the world. Describe the three types of plate boundaries, explain the landforms and natural phenomena associated with each type. The edges where tectonic plates meet are called plate boundaries. There are three main types of boundaries, each creating different landforms and natural events. Convergent boundary, moving together. At this boundary, two plates move towards each other and collide. Landforms. When two continental plates crash, they push the land upward to form fold mountains like the Himalaya. Natural phenomena. When an oceanic plate hits a continental plate, the oceanic plate sinks. This leads to volcanic activity and earthquakes. Divergent boundaries, moving away. At this boundary, plates pull apart from each other. Landforms. As the plates separate, molten rock, magma, rises from inside the earth to fill the gap, forming new crust. This creates features known as mid-ocean ridges, such as the Mid-Atlantic Ridge. Natural phenomena. The rising magma creates new land on the ocean floor. Transform boundary, sliding past. At this boundary, plates slide sideways past each other. Landforms. This movement does not create or destroy the Earth's crust. Natural phenomena. Because the plates are grinding past each other, this type of boundary is a major cause of earthquakes, such as those along the San Andreas Fault in the United States. Differentiate between weathering and erosion. Explain the different types of weathering with suitable examples. Both weathering and erosion are natural processes that shape the Earth's surface, but they work in different ways. The difference between weathering and erosion. The main difference is whether or not the broken material moves. Weathering is the process of breaking down rocks into smaller pieces right where they are. It does not involve movement. The rock just breaks down on the spot. Erosion is when Those broken materials like soil and rock are worn away and carried to a new place by natural forces like water, wind or ice. In short, weathering is the breaking and erosion is the taking. Types of weathering. There are three main ways that rocks break down. Physical weathering. This happens when rocks break into smaller pieces because of physical forces without changing what the rock is made of. Example, rocks can crack and break due to sudden temperature changes, the pressure of wind, or when water gets into cracks, freezes and expands. Chemical weathering. This happens when the minerals inside the rocks change into new substances because of a chemical reaction. Example, when rocks react with water, air or acids like in rain, they can weaken and dissolve, leading to the formation of new material. Biological weathering. This type of weathering is caused by living things like plants, animals or tiny microbes. Example, a very common example is when plant roots grow into the small cracks of a rock. As the roots get bigger, they act like a wedge and split the rock apart. Together, these processes are essential because they help shape the landscapes we see and play a major role in forming soil. What are the agents of gradation? Explain how running water, glaciers, wind, waves and underground water modify the Earth's surface. Agents of gradation are natural forces that work on the Earth's surface to wear it down, carry materials away and drop them in new places. Together, these forces act like a giant sandpaper and filler, leveling out the land by lowering high areas and filling up low areas over a long period of time. Here is how the five main agents modify the Earth's surface. Running water, rivers. Rivers are one of the most powerful agents of change. They shape the land through erosion, transportation and deposition. In the mountains, upper course, the water moves fast and cuts deep into the rock to form V-shaped valleys and waterfalls. In the plains, middle and lower course, the river slows down and begins to curve, creating meanders, winding loops, and oxbow lakes. Near the sea, it drops its sand and soil to form fan-shaped deltas. Glaciers. Glaciers are massive rivers of ice that move very slowly but carry a huge amount of weight, carving the land. As they move, they scrape away rock to create wide U-shaped valleys, bowl-shaped cirques, and sharp ridges called arites, leaving debris. When the ice melts, it leaves behind piles of rocks and soil called moraines, which act like natural dams. Wind. Wind is the main force in dry, sandy areas like deserts, where there are few plants to hold the soil. Eroding rocks. Wind can pick up sand and blast it against rocks, carving them into strange shapes like yardungs or ventifacts. Building dunes. When the wind slows down, it drops the sand into hills called dunes. These can be crescent-shaped burchens or long ridges. Waves. Sea waves and currents are constantly at work along the coastlines, cutting the shore. Strong waves crash against the land to create steep sea cliffs, caves, and even arches or stacks. Stacks are isolated rock pillars. Building beaches. Waves also bring in sand and pebbles to build beaches and sandbars, which act as a natural barrier for the land. Underground water. In areas with the rocks like limestone that can dissolve in water, underground water creates a unique landscape called karst topography. Dissolving rock. Acidic water seeps into the ground and dissolves the rock to form large caves, sinkholes, and underground rivers. Cave decorations. Inside caves, water dripping from the ceiling creates stalactites, while water hitting the floor builds up stalagmites. Describe the major landforms created by rivers. Explain the formation and importance of waterfalls, meanders, and deltas. Rivers shape the land by wearing it away, erosion, moving materials, transportation, and dropping them in new places, deposition. Depending on how fast the water is moving and the type of land it flows over, it creates different features. Waterfalls. How they form. Waterfalls usually form in the high, steep parts of a river's path. They occur when a river flows over a layer of hard rock that sits on top of softer rock. The water wears away the soft rock much faster, creating a vertical drop or cliff that the river then falls over. Why they are important? Waterfalls are beautiful natural features that attract tourists, which helps the local economy. The power of the falling water can also be used to generate hydroelectric power. Additionally, they often have cultural or religious significance in certain regions. Meanders. How they form. A meander is a large winding curve or loop in a river's course. They form when a river slows down on flatter land. The water wears away the outer banks of a bend and drops sand and soil on the inner banks, gradually creating curve-like shape. Why they are important? The soil deposited along the banks of meanders is very fertile, making these areas perfect for farming because the land is gentle and good for agriculture. Many villages and towns are built near them. Meandering rivers are also used for navigation and irrigation. Deltas. How they form. A delta is a fan-shaped or triangular area of land found where a river meets a sea, ocean, or lake. When the river reaches the end of its journey, it slows down completely and drops the large amount of sediment, soil, and sand it has been carrying over time. This builds up into new land. Why they are important? Deltas are incredibly fertile, making them some of the best places for growing crops like rice and jute. They support many types of fish and aquatic life because of the mix of fresh and salt water. Because they are near water and have good soil, they are often crowded with settlements and serve as busy centers for trade and transportation. Explain how waves and currents shape coastal landforms. Describe the formation and importance of beaches, sea cliffs, sea caves, arches, and stacks. Waves and currents are constantly moving across the ocean and acting like sculptors that reshape the land along the coast. They change the shoreline by wearing away rock, erosion, and dropping off materials like sand, deposition. Here is how different coastal landforms are created and why they matter. Beaches. How they form. A beach is made when waves drop off deposit sand, pebbles or small rocks along the shore. Why they are important? They are popular for swimming and relaxation, which help the local economy through tourism. They also act as natural barriers that protect houses near the coast from strong waves and erosion. Sea cliffs, how they form. These are steep, high rock faces. They are created when waves constantly crash against the bottom of the shore, undercutting it until a vertical wall is formed. Why they are important? They shape the beautiful coastal landscape and are often areas of interest for tourists and geologists. Sea caves, how they form. Waves find weak spots in the rock of a cliff and wear them away over time, carving out hollow spaces or holes called caves. Why they are important? Like cliffs, they attract visitors and contribute to the uniqueness of the coastal zone. Arches, how they form. When two sea caves on opposite sides of a headland, a piece of land sticking out into the sea, that's called a headland, grow deeper and finally meet in the middle, they create a hole with a roof, which looks like a bridge or an arch. Why they are important? They are dramatic natural features that are very important for tourism. Stacks, how they form. Over time, the roof of a sea arch becomes too thin and collapses. This leaves behind a single isolated pillar of rock, standing alone in the water, which is called a stack. Why they are important? These tall rock pillars are iconic landmarks that influence where people travel and how they use the coast. In summary, the constant action of waves either builds up beaches or breaks down cliffs into caves, arches and stacks, creating the diverse coastlines. Discuss the landforms created by glaciers. Explain the formation and significance of U-shaped valleys, CIRQUES, shocks, FJORDS, fjords, and moraines. Glaciers are massive rivers of ice that move very slowly over the land. As they move, they act like a giant scraper, carving out the ground and carrying away rocks and soil. Here are the major landforms they create and why they are important. U-shaped valleys. Formation. When a glacier moves through an existing river valley, its heavy weight and slow movement widen and deepen the valley. This changes the narrow V shape into a wide U shape with a flat floor and very steep sides. Significance. These wide valleys are beautiful and attract many people for tourism, especially for activities like trekking, skiing, and mountaineering. Some also have fertile soil that supports farming. Shocks. Formation. A shock is a bowl-shaped hollow or depression found at the very top, the head of a glacier. It is carved out by ice as it begins to move down the mountain. Significance. Like U-shaped valleys, shocks are major attractions for mountain climbers and tourists. Fjords. Formation. Fjords are deep, narrow inlets of sea. They are created when the ocean floods into a valley that was originally carved out by a glacier. Significance. Because they are deep and protected, fjords are excellent for fishing and serve as natural harbors for ships. Moraines. Formation. While the other landforms are created by carving, that is erosion, moraines are made by deposition. When a glacier melts, it leaves behind the piles of rocks, soil and debris called till that it was carrying. Types. Lateral moraines. formed along the sides of the glacier, terminal moraines found at the end of the glacier, showing the furthest point it reached, medial moraines formed in the middle when two glaciers meet and join their side piles together. Significance: moraines often provide fertile soil for agriculture. They can also act as natural dams to create lakes which people use for water supply, irrigation, and generating electricity. In addition to shaping the land, glaciers are extremely important because they are a major source of fresh water, feeding the rivers that people downstream depend on for life.